In this demonstration, I'm going to be showing you how Solid Edge preserves 3D intent from imported 2D drawings to imported 3D models. In this particular case, we're going to be looking at a couple of files from SolidWorks. We have a SolidWorks part file and its associated drawing. So the first thing I want to do is get the part into Solid Edge. So I'm going to import that into a Solid Edge part file. Then I'm going to go ahead and save that. Then I'm going to open up the associated drawing file. And we can look at the translation wizard. You can see that we get a preview. We can see all the layers that are involved. You can map all of the different aspects, such as the line type to a solid edge line type, and line colors to line widths. Once we have that in a Solid Edge draft file, we want to make note of a couple things. For instance, the drawing scale. You can see that the scale is set to 1 to 5. There's also a detail view that is 2 to 5. And that'll become important later as we go through this process. Now keep in mind, I'm showing you this on a couple of SolidWorks files. This would work on any imported geometry, such as something from ProEngineer, Mechanical Desktop, or Ideas, just to name a few. So I'm going to turn off the GD&T and the border layer so that we're just looking at geometry and dimensions. And what I'm going to do is run the create 3D command. What this is going to do is allow me to associate this 2D geometry to a 3D model, in this case the imported model. We want to make sure our options are set to include dimensions. We want to take along the linear, radial, and angular dimensions. And then we also want to define the scale, which is set correctly here. It's 0.2, which is 1 to 5. The front view is the primary orientation. So we can just begin selecting views. And we also want to make sure to get the top view and add those to the geometry. So you can see what happened. It took the 2D sketch geometry and it applied it to the 3D model in the correct orientation. So if we look at the different views, you can see the sketch lines up with our 3D model. So right now those dimensions are only associated to the sketch, but what we want to do is associate those manufacturing dimensions to the 3D model. So we have some user-defined sets here. The last one is a collection of all of them. I'm going to turn those off, and I want to do these one at a time. So if I want to associate the dimensions to the model, I could just right-click and attach PMI, and you can see that those dimensions actually jumped from the sketch directly onto the 3D geometry. And now those manufacturing dimensions become driving dimensions of the 3D. Another important thing about Solid Edge when you're importing files is we can maintain design intent on the imported file. Traditionally, when you're importing geometry into a foreign CAD system, you'll lose the design intent. So for instance, what I'm talking about is we have a couple of holes there that are aligned along the z-axis. If I edit this dimension, which is only associated to the bottom hole, and begin to manipulate that dimension, you can see that it maintains that alignment along the z-axis. If you look down here in the live rules, you can see that it turned green along the z-axis, which means it found that relationship and it's maintaining it for us as part of the design intent. We don't have to worry about it. So we change that to whatever we want and it will maintain that alignment. Let's go to the next view. And we want to also attach that geometry, or that PMI, to the geometry. Again, if I modify this dimension, if I make this taller, you can see that design intent is being maintained, that both sides are adjusting based on a live rule that says that those two are symmetric or coplanar. I also want to attach the PMI from the top view. See how it moved down, migrated to the 3D geometry. And once again, I can take advantage of these dimensions. I may want to lock this dimension. I always want this to be 25.4 millimeters wide. If I modify this dimension, watch what happens. You can see that the rib on all four sides or all four corners there is moving. And again, that's design intent. I want that to remain symmetric all the way around. And it does that for us automatically using those live rules. Okay, notice we have some holes along the side. We don't have any PMI dimensions attached to that yet. If we go back to our drawing, you can see that we actually had an auxiliary view. So I want to add that into our model. Scale's the same. Just run the command again and it brings it in there. Now what I want to do is actually manipulate that to get it in the correct orientation because it brings it in relative to its origin. Rotate it 90 degrees. And then I need to change the orientation of the steering wheel because what I want to do is put that steering wheel centered on a hole and then use that to align to a hole in our model. I'm going to go ahead and move this up just so you can see that it does in fact line up on that edge. And at this point then you can just right click and attach the PMI. Now that that PMI is attached, again, that becomes driving dimensions. And then finally, I had a detail view, an enlarged detail view of this particular area up here at the top. So again, I'll switch windows back to the drawing. And here's our enlarged view. Remember, this was a different scale. So this time when we run Create 3D, we need to set our scale to twice that, to 0.4. And just select that geometry and add it to the model. Again, we'll reorient the steering wheel and reposition it. Make sure it's on the end. And then I'm going to move it in plane up to this endpoint. And then I'm going to attach the PMI dimensions to the model. So once we have that all done, you can see that now we have all the manufacturing dimensions have now been attached to the 3D model. And it becomes a fully synchronous solid edge model at this point with all those manufacturing dimensions. I'm going to save this, and what I want to do now is actually create a drawing from this. So I'm just going to go to the Create Drawing command, and now what we'll do is just I'm going to move these views around just a little bit, and then I'm going to retrieve that PMI dimensions onto these onto this drawing. So just run the retrieve dimension command, select the views, and it retrieves all the dimensions associated with each particular view. So you can see the dimensions that we changed are all correct. So you can see how powerful Solid Edge is for importing geometry from foreign CAD systems, 3D geometry, and the associated drawing file with all the manufacturing dimensions, and then actually attaching those manufacturing dimensions to the 3D model and making it a fully synchronous solid edge model.